Hi. So my name is SeungJin. Let me introduce myself shortly. But I have to say I don't speak well, so please be patient for my talk. So I'm from South Korea and graduate school in university in Korea. And I'm highly interested in open source security research, vulnerability hunting, or exploiting them, and reverse engineering, some kind of that. And I work for big companies in Korea, so I'm a part-time student. And I highly like to play hacking contests like Debugging CTF. And I run hacking contests and conferences in Korea as well. I have spoken at the security conference at like SysCan, Evidocus, CanSec West, Secure Insight. And about this talk, I will firstly mention about the research motivation and introduce to what is a smart TV and smart TV surfaces and rootkit, like persistent to shells or the work making the TV work for 24 hours and surveillance program and things like that. So okay, this talk is more about security bugs and rootkits than about the firmware. I think you must know if you are interested in some the smart TV security, because there is open forum on the internet called the Samigo, right? But this is not about the firmware itself, but more about the security bugs and things like that. And also, this talk is more focused on rootkit, like a surveillance program or things like that, because in smart TV, the vulnerabilities or exploiting techniques are almost same to the traditional ones. So I don't want to talk about it much. And okay, this talk is talking about general security smart TV issue, not about the specific vendor's TV, which is starting with alphabet S, because the vendor asked me to not mention the vendor's name directly, but I'm pretty sure you guys already recognize the TV, right? Where is it from, right? So okay, research motivation. The smart TV is being really popular. In last year, there are like 80 million smart TVs sold, and which is really impressive for me. And it definitely going to be more popular. But even though it's popular, but there are no security research on smart TV. Okay. So smart TVs, as you know, is used in many fields, and home entertainment, office purpose, and educational purpose, and blah blah blah. Okay, I will skip it. Yeah, this is not from me. This is from the industrial guy. So they say like this. So many companies these days they make smart TV and smart TV. But in my opinion, smart TV is just a regular PC. But it shows you TV programs, and you can do things in the smart TV. And fancy smart TV like this one, I brought this one from Korea. It has the camera and voice sensor inside. This one is the latest model from the vendor, and yeah, this is quite expensive. I have to spend 3,000 for this one. And yeah, as you can see, the top and left, you can see the camera, and the right, the one is for the having remote control signals, which means IRDA. And the back looks like this. There's a LAN cable and X-Link, USB slots there. So this one is using a modern operating system, I mean the Linux. And the CPU is obviously ARM CPU. And there are a lot of code which is by the vendor. So it actually works like just a regular PC. It loads the kernel and executing some programs and scheduling inside, and yeah, things like that. So camera and mic. So as the TV can recognize your motion, you can even turn the TV on by your motion. I mean, you move your arm and just move your hand, and And you can select any menu on the TV, and you can turn on the TV by your voice, for example, Hi TV, something like that. So I have to mention at the first the big hurdles of smart TV research. As I said, no documentation, no research, but there is a Samigo, as I said already. And the TV is a black box, so no source code. And smart code is really huge. I mean, by the vendor. The vendor has made a lot of code. So there are over 100 megabytes for the binaries, which means it's really hard to find some interesting spots. I mean, so there was a really big hurdle. And the hardest one is that if you do something wrong, your TV, your research can break your TV. So sometimes the factory reset doesn't really work. So you have to send your TV to the AS center, the vendor, to make the vendor to fix it. So I did it 2 times, but I didn't say anything. So yeah. So I have to say the smart TV has almost the same attack vectors as a smartphone. Things like this. There's the application market, and there's also attack vectors like man in the middle, or when you do web browsing on the internet. And there's also physical attacks, like you put malicious USB stick to the PC, and this is the same. So the first, when you research on a smartphone, you have to do routing at the first, so that you can do things in the smartphone. The same in the smart TV as well. You have to get a shell at the first. So, there are really not much information about the TV from the vendor. So I had to go to the Samigo. Because this Samigo forum has a lot of information about firmware, and if I get the decrypted firmware, so I can do a static analysis. So which means I could try to find some interesting spots. So, but unfortunately, the Samigo at the time, they didn't have much information about my TV, because this one was really brand new, and so. So we got an older version and different model firmware, but we could decrypt it because there was a password for that on the Samigo forum. But I have to say the binary were really old. So, but what I said before, the code is really big, so there must be same code in between the older version and the latest one. So I have the binaries, and we have also IDA. Okay, as this TV is using ARM CPU, the IDA analyzes really well the ARM code. Also, I was trying to use UART to get some debug messages by the programmers. But I'm a really hardware newbie, so I will mention very quickly about this UART stuff at first. So fortunately, the programmers make a lot of debug messages for them, actually for not us. But if you can connect the UART to the TV, you could see a lot of debug messages like segmentation fault or some debug message, things like that, and some strings really that might be really good hint when you do a static analysis, for sure. So you have to make the UART feature enabled, but in default it's disabled. So you have to go to get into a service mode in the TV. There are actually 2 ways to do that. One is power off, mute 182. I mean using your remote controller. But the first one doesn't provide us advanced mode, so we have to choose the second one, info factory key combination. But our remote controller doesn't have the factory key, so we have to make the signal by some way. So we got some hint from the Samigo. They are the two code for the info and the factory. I mean OX1F and OX3B. Yeah, so we use the Arduino and Bus Pirate to get into the advanced mode, and we made it to we made the UART feature enable. So, yeah, this is command for that. So after this one, you can make it enable, and you could see all the debugger message from the TV. But if the Samigo site has your firmware, just use it, because they offer you some ways to upload modified firmwares to the TV, which means you could get the shell very easily. So that's a more easier way. So the TV is a black box, but we still have the binaries and UART, which is really nice situation. So the basic approach is that the reversing binaries in a static way, and finding some interesting spots to test, and checking the response from the TV. I mean the UART message, and you do this by repeatedly. So as I said before, our not much mention about the artifactors, because it's almost the same to a smartphone. So, but anyway, the first one is a Smart TV App Store. You can imagine that the Smart TV App Store is almost the same as like Apple App Store or Android App Store, things like that. But you can only so you can make your program, which can be running in the TV, but you have to write in not native languages like C or C++. You can only use JavaScript or HTML or Flash, things like that. I'm not sure, but this might be because of the portability or some security policy. Not sure. Actually, there is a guy from Samsung. You could ask him later. I mean, at this conference. So, so I think that the vendors wanted to try to prevent the bad guys from uploading malicious programs, definitely. So this is a test scenario. You upload your malicious application to the market, and the users download the bad application and infect it. Very simple. So what is to write in JavaScript and Flash for application? It means that you cannot call the system call directly, or you cannot access many resources like a file system, or because the application is running in a virtual machine. So you basically cannot do much with these languages unless if there are some security bugs inside. And there are also other attack point factors like using web browsers. So I will mention it later more about it. So, but without for example, without the file I/O API, you really cannot make applications, because you have to use a database or things like that in modern application. I mean, most of the application. So the vendors provide you some SDK and API to use some APIs like accessing file system or using some network traffic, things like that. So basically, there is no sandbox. I mean, there's no sandbox architecture inside, but they heavily rely on the API security itself. So they are trying to do some sanity check in almost every API, but there are a lot of APIs, so it's really hard to make it sure. So for example, this one ensures that you cannot open any files outside of some strict directory. Yeah, so I have to say the API level sanity check is not passed away. So they might be very careful very sensitive API like a file system I/O, file I/O API. But what about the audio control API? Nobody cares about it, but there might be some bug inside. And the other problem is that all the application is running as a root privilege, so there's no separated. The first one. So I've found the many the bugs, but I will open some of them because I will tell you the reason later. The first one, when you make your application, you have to provide an XML file to the TV, I mean to the end market. It has to contain the application name, a title, compression, description, download. Download is the URL you provided, and zip file format. So as we don't have much time, this is the ARM code. This is really bad because when you trace down these APIs, it goes to the underbar GN13, CNN, Devi app-based things like the exe shell. It does system by the calling free fork or wait PID exe shell. It's almost the same as system function. So it passes the argument to the system function. So if as I told you before, our download URL is the zip file, so which means it passes our value with to the system function, and there's a prefix binary, the bin unzip. Of course, there's a sanity check like for pipe and semicolon, but they missed some Linux special characters like a tilt, which means you could execute multiple commands at the same time. But there was a hurdle, a tiny hurdle, because you cannot use you cannot use slash character, but you can use the environment value, or the PWD, because the installer is a background application, which means the old PWD will be having always the slash the value, so you can use that one. Yeah, the other one is a memory corruption in the XML file. You can see that there is a C-string concate EPC PKC. It passes our value to the function, and it does exactly the strcat. It's actually a wrapper function. So you can see that the register, the PC, so 61, 61, 61. PC is a program counter. You can think that EIP in x86. So the others, there are really many APIs that use a system function still and memory corruptions. So yeah, so you can easily get the shell using this box. So you can trace down the APIs. Yeah, go. Yeah. So I'm pretty sure there are more, and there are more and more, but I cannot disclose all the bugs. But yeah, so you can see the quality SO box. You may find it. I mean, this is really 1990 box. Yeah. So the other one. Yeah, this is also very traditional artifactor. Like when you surf on the internet. So there's also other artifactors. I mean, there's like a Facebook application inside. So which means it's working like a online messenger, IM. So which means you can do active octet, because you can send your photo or link or the images, video to your friends. So, and there are some inside. Yeah. So also the web browser has a lot of problems because, as you know, it's really hard to maintain all the patches latest especially in embedded systems. So this is also same. You can see the version inside. The Flash version is the 10.1, which is very old. And the kernel, I don't care about the kernel version, but the Flash version or wacky version is are really serious problem. It's like surfing within a web browser from many years ago. So, and there are really many network demos. It's not because it's not for the FTP or things like that. So they they offer you really rich features, experience to users. So, for example, the port 55,000, they process our packet and they provide us 20 commands. Actually, many of the commands are not undocumented, but some are really having serious problem. I mean, in a security point of view. So, for example, the command number 121 RSA decrypt or so 130, they have some. They don't need you authentication. They don't need to be authenticated, but so which means you could use all the commands without any auth. So, for example, the command 121 has a memory corruption bug inside. So, which means you can hack the TV. But I have to say, I know it's exploitable, but very randomly because I cannot control the value. So you have to do some like a heap spraying, things like that. So yeah, the 66. I'm mentioning this stuff very quickly because I wanna talk about the surveillance stuff. So more about it. So the UPnP has a lot of features inside. Also, two services in UPnP. You have to be authenticated, but the other 4 services you don't have to be authenticated. So man in the middle, there are a lot of man in the middle issues inside. For example, the sending credentials without the encryption, and also the hacking application by some injecting malicious payload inside, because there are really many packets without SSL. So, and there's yeah, no sanity check or things like that. Yeah, also there's some USB driver bug inside, which means that you can put malicious USB stick to the TV and it just pawn. I mean, you have to be around the TV to try this attack, but anyway, so this is getting popular this way. I mean, not for TV, but for PC, yeah. So there are some interesting artifactors as well. We were trying to find some memory corruption bugs in the code, the parsing the remote control signals, because it's like a ASN.1 style, the parsing code, but we failed because it was really tiny, the code itself. So, and broadcast signal, this is also should be mentioned because the vendor provides you to update your TV within the 3 ways. One is a USB stick. Second one is by internet. The last one, you could update your TV by broadcast signals, which means if you could send your signal very strongly around the target TV, maybe the TV will catch your signal instead of the signals from the vendor. So yeah, okay. So yeah, at this moment, I need to So I'm listening on 80.0.80 port within the NC to get a reverse share from here. I will talk about the reverse share later. Okay. Yeah, so because it means the signal is really weak, so you cannot see the TV program. Sorry, it's Korean. So as I told you, the TV, if you have a shell inside, it's just like a regular PC. So which means you can do whatever you want as you do in PC or laptop. So it's possible the hijacking TV programs and keylogging and capturing the TV screenshot, the snipping, network traffic, all the things are possible. But we first need persistent shells from the TV. Actually, there are, I want to say there are 3 general ways for that. One is rewriting the firmware, but this might be very risky because each embedded system. It couldn't make the TV a brick, so which means you have to send the TV again to the AS center. I don't want to do that. The second one, I'm not sure about this issue, but remounting sometimes doesn't work in embedded system. It's not working in this TV as well, but I didn't try to figure out because I choose the third way. Just as it uses the Linux system. If you find some shared library inside, like .so files, but they are not loaded by the programs. So you see this slide. Yeah, we made a simple Linux kernel module which hooks the system call, sysopen call, and checking if there are any error numbers. It indicates to no such file directory. Within the .so file extension. It means if we put some fake SO files in our directory, which the program's reference, so we can run our code during the loading. So we found some, and we put some reverse engineering shell inside, and yeah, we got it. This is from the library, the backdoor. So every time when the TV boots up, I got a shell from the TV. So, but the problem is that there is protection program by the vendor called the UEP, but this is not that robust. I would guess that UEP stands for User Executable Preventer. So it checks, it scans all the directories, all the files inside of TV, and checks if it has the valid signature or some correctly signed. If it's not, the daemon deletes the program, which means our shared library is not signed by the vendor. It will be deleted by this program immediately. But the problem is that as a UEP has to scan all the directories and the files, which means it takes time. So your file will not be deleted immediately. You have time to do something before the preventer. So the solution is very simple. You just kill the preventer. So sorry about that. Yeah, actually this is really not a good idea because it doesn't actually prevent stuff, but only gives some bad performance to the TV because it has to scan the directories of files all the time. Yeah. Okay. I asked around 100 friends around me. So what's the worst case if the smart TV got hacked? So one is stealing financial stuff, and second hijacking TV programs. Yes. So obviously the number 4, most of people have chosen. Yeah. Yeah, I just got this photo in the morning. So I want to try some Photoshop inside with my face, but I'm lame. Yeah. This is about some surveillance movie, right? Okay. Okay. Still, 85% is really high, but I think the 15% didn't exactly understand what I'm doing in a smart TV. I mean, pwned smart TV, because most of them were not computer experts. So the TV has a camera and a mic inside. People. I take about the surveillance program, how to implement it. I want to mention about the stuff between the smartphone surveillance and the smart TV surveillance. Smartphone, as you know, smartphone has also mic and the camera inside. But have you ever tried capturing the photos using the pwned smartphone? I did it, but it didn't really work because, I made a simple surveillance program in an Android phone, and I went out with the phone. And after that, I got two problems from the test. The one is that, so after having really many photos, so only one lesser than 1%, you can say they are just okay. But most of them, I mean, over 99% pictures, they are really useless because most of the time your smartphone is in your pocket or on the desk, so they don't watch you usually. So, and the smartphone is moving very quickly, so the most of the pictures are really blurred. The second one, so it's a shame, but I don't take photos much using my iPhone. But I realized that the taking pictures takes a lot of power. So after just hours, your power will be your phone will be dying because it takes a lot of power to take photos. But smart TV, there's someone who pulls out the plug at the home from smart TV. Maybe no. Yeah. So as a smart TV, I mean, all the TV is connected to the power 24 hours, maybe, I think so. And TV cannot move, which means he's a really good photographer. And surveillance, it's not about me, but it's about your family or the people you love. Because I don't care if somebody is watching me, my naked body, but I worry about my girlfriend, my family. So do not make a TV see your bed. But that's my advice. Also, the TV cannot go to your office, which means it may not steal the business information or things like that, but it's more steal your very privacies. So. The privacies, I know that in Germany and Japan, the privacies are really the issues. So, and to implement that surveillance tool, you have to do some debugging because the most of the code are written in C++. I tried to use a ported GDB, but it didn't work well because the binary was really huge. So it worked, but it didn't go really well. Sometimes many hangs without no reason from me. We tried to find a better one or implement one. But fortunately, we found a nice tool by Colin Mulliner. It's a Android DBI, dynamic binary instrument tool. So you can find it with this link. So the Collins DBI tool, it works, it tracks the target process and changes the PC registers. So it executes a shell code and it does DL open system call. So actually the DL open code is in the stack, which is not executable, but it directly calls mprotect system call, mprotect actually, function, and to make it executable. So it basically does the hooking, some stuff. So it's but it works really nice. the TV still. Yeah, this is the sample code. So the above code is to set up a hooking code in a function, and the follow one is the actual hooking code. So if you put some code like this in a hooking code, it's really good for debugging, because as you know, C++ it's sometimes really hard to trace down who is calling or who is called, the functions. So we want to use the DBI tool to know that very easily. So as you see that we are dumping the LR registers and PC register, or the argument register to see the value. So we print we print a message to the standard output. So we had to make some Linux kernel module to see the message, but we didn't have to do that, because you could write down into a file, not just standard output. But anyway, there are also a lot of debug messages by the developer, but unfortunately, for the release version, those debug messages are not available for the binary. So, but if you see the code inside, there are the global variables. It checks it. We could say that it's a debug low address or debug high address. So if you set those two global variables like this, like one is 000, the other one is 3030. So we can reach to the printf message. Actually, as this binary is really huge, and so that if you can watch the debug message, it's really helpful. You can do that using the ptrace call, and this is the part for making the TV 24 hours. Actually, this is a lie, because I don't watch TV at home. So I don't have TV basically. So we want to make the surveillance program working 24 hours, even though the users turn off the TV. And so we had to find some trick for that. But for the record, I have to say this: I usually find the vulnerabilities and exploiting the bugs and reverse engineering. I never make any surveillance tools or rootkits. This is my first time, but I had to do this because the vendor said to mass media the red text by bad guys taking pictures might be possible, but that's impossible when the users turn off the TV. So that inspired me. That's why I went to make the TV 24 hours working. Because it must be possible, because it's software, and when you send signals from your remote controller, it's just software, so you can do anything, whatever you want. So I don't want to show you the really long ARM assembly code, because it's really huge. So I will just write down the function's name. So we have to find the functions that are related to the turn on or turn off features when we send the signals to the TV by the remote controller. So there are a lot of functions, but mostly the TCTV colon power, the function shows that. So when a user press the power off button, it does off the screen, off the sound, off some processes, but not the kernel. And finally, it reaches to the TCTV colon power. So actually turn off. So actually, There's the blue LED here, but you hardly see that because I put some sticker inside to not show the vendor's name. Yeah, sorry about that. So, yeah, at this time, the TV looks very turn off without except this LED because it's still lightening. So to turn off the LED, you have to call this function with the argument 0. After that, yeah, the TV looks totally turned off. Yeah, so users may think the TV is actually turning off, but our rootkit still working inside. So, but at this moment, we have to put another hook code at the TCTV, the : power function again, for the moment when the user press the button to make the TV turn on. So, with argument 3, the LED will be lightening again. Yeah, so there's also the function called the TDS system, the set power. If you call the function with a 0 argument, it does a fast reboot and the TV screen out sound process go up. So I have a shell, but as this goes to fast reboot, I got disconnected from the TV, but it's okay because we have a persistent shell in the box. Yeah. Yeah. So basically, users never realize there's something inside his TV, rootkit or something like that. So we've done so far how to get shells from the box and some tricks for debugging and the persistent shell, the 24 hours working. So now it's time to cover the surveillance part. So we've made 2 surveillance tools. One is taking pictures and sending them to the server, which is by me automatically. And the other one is the video recording and live watch and remotely, and it shows you lively. So we will cover both how we implemented the tools, and I mean shortly because time will lag. But we'll only give a demo for the second one because I just guess the video is much funnier than just photos. Yeah. So we again have to do a reversing again to make it. Yeah, we could use the camera device driver directly, but yeah, try to know what user level functions I actually use for it. Yeah, there were 2 ideas at the first to implement the program. The first one is the API provided by the vendor, learning the API. So we could make the tagging the pictures app very easily because the vendor actually provides you those APIs. So if you use the APIs, you could make it very easily. But we were worried about if we made a program and within the APIs by the vendor, it might be not working in the background. So there might be a possibility that the users will recognize our program. So we went to the second option, just understanding how the camera app works. So yeah, I take those process in this slide very abstractly, but it first open a file. I mean, it first opens socket and send some commands, which is by the vendor, like a camera stop, sec cam streaming, and set mic, things like that. So I will pick one of the commands here. For example, you see the sec cam the display, video display size command, and the protocol is really simple. So the first one, the length of the command, and the command, the argument is, length of argument, the value of argument, and so on. So if you dump the packet in here, things like this. So if you do this, so you could take a picture, and it directly save the picture into a file, and so you can just get the file. Yeah. So now it's for the taking the video. Yeah, you can take pictures. Yeah. So for taking videos, it's slightly different to the taking photos because the buffers, the video streamings, in the capturing process, taking picture, it saves the image file into images into a file, but when in those taking movies, it never writes to the file. Yeah, so we had to find a way to dump the buffer so that we can write it into a file. So as we did for the taking pictures surveillance tool, we again had to do reverse engineering. To take the clip, those functions are called, like this. And you see two functions here. The last second, the CMO IP buffer, the read, it sounds like very good for us because we could just set a hook code and dump the buffer into a file. But at start render the function here, yes, here, we found a better way. So when you see this ARM code, so by the way, we have to go to good location because if you can be at good location, the code opens the file and just dumps the buffer into the file. I think this is for some debugging stuff, but normally for the release binary, the value of this comparing is so it normally go to the better location, which means you have to do runtime patching again. By this way, you could change the value, so not to the 0. So we can always go to the good location, so that the code will be the opening a file and saving the buffer into the file. So now we have the video file, and now it's for okay. Yeah, so this is demo time. Yeah, I've tested this a lot, and I never got demo gas yet, but this might be my first time. But anyway, I will try. Yeah, I still have the shell inside. Okay, I will download the desktop. Yeah, those hijack tool or blah 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 for the making the TV 24 hours or surveillance tool or things like that. Yeah, so I'm using the internet using my tethering iPhone here from South Korea. So slightly, yeah. Be patient, please. Yeah. So yeah, this is a module for making 24 hours. So I'm trying to inject it, and now for the part of the recording the clips. Yeah. I really hope this demo is going well. Yeah. for the party tonight. Okay. Almost ready. Okay. As I told you before, for the show, I made a simple streaming program, but this is for the demo, so the streaming program is really poor, so there is some delay. Okay, I'm almost ready, I think. So this is my first time to make the streaming program. So okay. So I have to execute this program. Okay, before doing that. Okay, the recording program is starting, and this program is trying to get the buffers from the site, and this will. The first time it stops, but oh fuck! So you can. There must be someone because you can. Yeah. Okay. Thank you. Yeah. Please, yeah, you have to sit down because I have to play again. So there's one more. There's a delay. Sorry about that. I'm poor streaming programmer. So the TV is working, but as the 24 hours program is still running inside, which means after I turn off the TV, but it's still this recording program have to be working, right? Oh, okay, I see you. Okay. Okay. I'm now going to turn off the TV. And there must be delay, so wait a second. Okay. And okay, there's no blue LED light as well. So we could wait like 30 seconds, 1 minute, things like that. Yeah. Oh, okay. Oh, okay. I'll try. Okay. Wait a second. TS file here. Oh, it seems the demo is going well. Not going well, but it does, the shell is still open. So if you want to do this again, the TV is turned off. Okay. Okay. If it shows the guy, yeah, it probably. Okay, yeah. To make sure more. Oh. Yeah. There must be me sooner or later. Oh, his leg still moving. Okay, there's me. Okay. Oh. Okay. So, yeah, the conclusion is fairly simple. the TV hacks doesn't make as much as like a smartphone hacks, but it's more about the personal privacies. And as we said before, the power is already always connected, and the camera and voice sensors inside, and it can be located at very privacy places like around your bed, and almost no noise while running. I mean, you never realize that the TV is working 24 hours because there's really no noise. The vendor makes the TV very well. Yeah. So, yeah, this is thanks to. Okay, thank you for attending my talk.
So thank you very much. I think one lesson learned: don't watch TV. Go and buy paper books. Maybe they are quite harmless. Questions, please.
Yeah.
Great.
So if you've got a remote shell, could I remotely turn the TV on and then display something on the screen?
Yeah.
Sort of en masse?
Yeah, right. Cool. This is all about software, so yeah. Unbreak it?
Fuck something up.
You could ask the Samsung worker here. Okay.
24-hour service.
In Korea, it's free to send your TV, broken TV, to the AS center, but I don't know the situation in Germany. Okay.
Okay, more questions?
So
okay.
I have a Twitter and the email. So if you have other questions later, feel free to contact me.
Okay, so thank you very much.
Thank you.